Welcome, students. We have started the chapter of Is Matter Around Us Pure, and so far we have discussed about the pure substance, the one which is made of same kind of particles. And as I have told you that all the elements and compounds are pure substances, and so far we have discussed about elements. Now today we'll discuss about the compounds. Compounds are also pure substances. But what is a compound? So let me tell you, a compound is a substance which is made up of elements. When two or more elements combine chemically in a fixed proportion by mass, they will form a compound. So compound is made of two or more elements chemically combined in a fixed proportion by mass. Let me make you understand this. For example, we are having water. Water is a compound because water is made of two elements, hydrogen and oxygen. And hydrogen and oxygen, they chemically combine together in a fixed proportion of 1:8. It's actually by their atomic masses. As we are having H2O as water, so the atomic mass of hydrogen is 1 unit. The atomic mass of hydrogen is 1 unit and the atomic mass of oxygen is 16 units. But here two atoms of hydrogen combined with the one atom of oxygen. So if one atom of hydrogen is having a mass of 1 unit, so two atoms of hydrogen are combining, so it means 2 units of hydrogen are combining with the 16 units of oxygen, right? So 2, this is 8, so the ratio is 1:8. So basically hydrogen and element, these two elements, hydrogen and oxygen, these two elements combine in a ratio of 1:8, 1 part of hydrogen and 8 parts of oxygen, and form water, and water is nothing but a compound. Similarly, we are having other compounds also. Sodium chloride, NaCl, that is also a compound made up of two elements, sodium and chlorine. Ammonium chloride, that is also a compound made up of three elements, nitrogen, hydrogen and chlorine. Sand is also a compound. Sand is actually silicon dioxide. It's a compound made of silicon and oxygen. Marble, that is actually calcium carbonate, again a compound made up of calcium, carbon and oxygen elements. So there are a lot of examples of compounds. Ammonia, carbon dioxide, ice, that means water, steam, that is also water, chalk, limestone, methane, glucose, starch, baking soda, potassium sulfate, copper sulfate, hydrochloric acid, sulfuric acid. These are all the examples of compounds. And here I have wrote some compounds and the elements which are present in those compounds. Sodium chloride, that contains sodium and chlorine. So I have written here the constituent elements present in the compound. So now the compounds, these can be further divided into three classes: acid, bases and salts on the basis of their properties. Like we are having a compound of sulfuric acid, that is an acid. We are having compound sodium hydroxide, that is a base. We are having compound sodium sulfate, that is a salt. Okay, but you will discuss about all these acid, base and salts in your future. So here let's study the characteristics or the properties of compounds. So the first property of compound is that a compound has properties that are different from the properties of its constituent elements. It means the properties of compounds are entirely different from those of its constituent element. Let me make you understand with this with the help of an example. So let's take an example of water. See, water is made of hydrogen and oxygen, right? So if we look at the property of water, water is a non-flammable material, right? It is a non-flammable liquid, right? But it is made of hydrogen and oxygen. And if you go for hydrogen, the hydrogen is extremely flammable substance. And if you go for oxygen, it's a supporter of combustion. But look, water is having entirely different property from its constituents, from those of its constituent hydrogen and oxygen. So that is why we say that the properties of compound are entirely different from those of its constituent elements. Okay. One more characteristic is that when a compound is formed, there's usually an exchange of energy in the form of heat energy or light energy with the surroundings, or sometimes both. That means energy in the form of heat and light is usually either given out or absorbed during the preparation of a compound. So basically, formation of compound is a chemical change. Let us take an example of iron fillings and sulfur. When iron fillings and sulfur are heated together, they form iron sulfide. Iron sulfide. So basically, when they are heated, they form iron sulfide. So once the reaction starts, a lot of heat and light are produced during the preparation of iron sulfide compound. So iron sulfide is a compound, and for making this compound, for preparing this compound, we need a lot of heat. Lot of heat and light is produced during this reaction. So whenever a compound is prepared, either the energy is given out or absorbed in the form of heat and light. So formation of compound is a chemical change. Another characteristics of compound is that a compound can only be broken down into simpler substances by chemical methods. Like decomposition by heat energy or exposure to light or passing an electric current through it. So that means a compound cannot be separated into its components by physical methods. We have to apply some chemical methods to break down a compound. Let's take one more example here. Suppose we are having a compound of iron sulfide. We are having a compound of iron sulfide, and say a magnet is put in this compound. Now we know that iron gets attracted towards the magnet, right? But here, when we place magnet in the compound of iron sulfide, iron does not get separated from the compound, from sulfur. It doesn't attract the magnet, doesn't get attracted to the magnet. In fact, if I use carbon disulfide solvent, because sulfur gets dissolved, sulfur gets mixed with, reacted with carbon disulfide. But if I use carbon disulfide solvent here, that also cannot separate sulfur from this iron sulfide compound. Why that doesn't get, why iron doesn't get separated? Why sulfur doesn't get separated from this compound? Because iron sulfide compound, it's actually a compound, and we cannot separate a compound into its constituents by physical method. So when I'm placing magnet there, when I'm dissolving, adding carbon disulfide, it's actually a physical method, and we cannot separate a compound by physical method. We need to use chemical methods. Either we need to apply heat energy, we need to give light energy, or we need to pass an electricity, so that a compound gets broken down into its constituents. One more characteristic is that the different elements in a compound always join together in a fixed proportion by mass. As I told you that when a compound is formed, elements get combined together in fixed proportion by mass. That means in case of hydrogen, in case of water, I told you that it's actually 1 part of hydrogen that is combined with 8 parts of oxygen. So ratio is 1:8, so that the water gets formed, H2O gets formed. So elements combined in a fixed proportion to form the compound. So constituents are present in fixed proportion by mass. And that is why a compound is having a definite formula. Suppose we are having water, there's a definite formula for water, that is H2O. Okay. There are other characteristics also, like a compound has a fixed melting and boiling point, and a compound is a homogeneous mixture. So these are all the characteristics of compounds.